Hello, this is Joe with joesastrophoto.com. Today we're going to take some bad data and hopefully make it into a usable image. So the moon's been full for the last 3 days, or close to full, and it's also been cloudless nights. And instead of wasting those nights, I decided to try an experiment. I wanted to see what it would be like to take some narrowband images and right next to a full moon. And so that's what I did, and as you would expect, the data came out pretty washed out. And as luck would have it, and it was unintentional, but I screwed up and I framed, I got different frames every night. I don't know how I did it. I've never had that happen to me before, but every night's worth of data for the 3 nights in a row were framed differently. So that adds another challenge as well. I wanted to start off by showing you some of the individual sub-exposures through B-Link. And you could see that there's a lot of clouds or haze in the sky, plus there's a almost full moon out, and this is back to the beginning. This is over the course of 3 days. It's actually 28 hours worth of data, and it's all pretty bad. The Tadpole Nebula isn't even in the same place in each frame. And I'm pretty sure that when we go to stack this, we're going to notice a lot that we're going to have to crop out. But I just wanted to run through these real quick, just to show you a few. There's some good hydrogen alpha shots. So not all the data is awful, but it's not good. And this is still pretty washed out from the moon. These are 3-minute exposures at a gain of 200. On an ASI 1600 monochrome pro. You can just see this washed out area here. So I'm guessing that the gradients are going to be extremely difficult to control. So I'm going to close this and start stacking. So PixInsight just finished stacking all of the exposures. It took about 2 hours, and now we're going to open up our masters. I already see as it's opening, these are going to be pretty bad. There's our rejection high and low, just for the sulfur filter. I had a feeling it was going to be something like that. So I'm going to end up having to crop a lot off the image. Hopefully we'll even get it. I'm going to go ahead and close the highs and lows. Okay, I think we're gonna be okay. This is very interesting. I'm not even sure how it actually happened that I imaged off frames like this. It was kind of an accident, but it was a lucky accident because the whole point, I was trying to experiment to see if I can make a decent image out of bad data, and I don't think it gets a whole lot worse than this as far as being washed out with the full moon and completely different frame structures. This will be interesting to see. So I screen stretched these, and now I think we're going to have to do a crop to start with. And I think I'm going to use this oxygen master to crop with because I could see the line here. I don't know how that falls in with the other frames just yet, but I'm going to give this a shot and then see what it looks like. Looks like I can't. About right here is all I could get. And in all honesty, I'll probably end up cropping more off of the left to kind of center this up, or at least get it in 1/3. If it's not there, it'll look a little strange in a picture. I think if it's got a lot of empty space here and then our smaller nebula. But let's see how this turns out. So we'll apply this to our hydrogen alpha and our sulfur, and then execute it on our oxygen. All right, so we don't have a lot of data. And another issue that I believe we're going to have now is that we're going to start to get a lot more grain, because we're going to have to go zoom in a lot more. Well, we'll see what we could do with it. I still see some strangeness here. So I think we're going to crop this later as well. So the first thing we're going to do is go to processes, all processes, and do a linear fit. And what this does is it makes all of the backgrounds the same level of brightness. And usually I take the hydrogen master and apply it, and I think we will. So this time as well. So I just use that as a reference image and then just apply this to the other two images. And then we'll just re-screen stretch this. And now all of the backgrounds have the same brightness. So when we actually use pixel math to combine them, should have less gradient, but I could see just the massive amount of gradients we're going to have. If you've seen my other video on when to do your background extraction, and I found that it's easier to do it after they're combined instead of on each individual, because you pretty much get the same. This might be the exception to that rule. I'm going to try it though after they're combined, but they're really off. So, but that's the point of this. So we'll see how this works. So I think I'm just going to go ahead and combine these, and I'm curious to see what we're working with. I'm going to change these identifiers real quick just to make it easier on myself. Sulfur. Our hydrogen's going to be green and our oxygen will be blue. We're going to create a new image, and it's going to be an RGB. We'll do a screen stretch. And yeah, I've got my work cut out for me here to try and make this a usable image. Wow. Lots of color gradients. All right, well, let's close that. And I think this is going to be one of those trial and error times. So I'm going to make a clone of this, and we're just going to work with the clone. And then I'm going to roll up the rest of all of these images and get them out of our way. That way, if I mess up and I don't want to go do a bunch of edit undos, I could always just open up that other image. Well, the first thing I'm going to do is dynamic background extraction. I don't think the automatic background extraction will work on this, just based on what I'm seeing. I'm gonna change our default sample radius to 150. I'm gonna leave this at 10. I'm gonna change the tolerance to 2 and our shadow relaxation to 6. And I'm gonna generate this. And I am going to just use the border. And I think I'm gonna remove these because it's hitting some of the nebula here. Okay, we're gonna give that a try. I'm gonna pull this off over here to make another one, and then we'll do a division first. Close this and rescreen stretch. Well, it's not bad. There's still strange stuff, but let's see what the subtraction does. Come in here, go to subtraction, do the same as we did for the division. So the next thing we're going to do is a multi-scale linear transform, and that's going to clean up some of this background noise because it is extremely grainy, which was to be expected. So I'm going to make a preview, and I kind of want to grab some of this background, and I'm going to drop down this linear mask. I'm going to turn the screen stretch off because that's the way that this preview mask works, is with the screen stretch off. And I'm going to change the luminance because it's an RGB now, so the target's going to be RGB. And I'm going to turn on the real-time preview, and we'll see our mask here. And so pretty much everything in this that's colored isn't going to be affected, and that looks pretty good. Now the way you can change this is with the amplification slider. It's set to 200, and I'm just going to move it up so you can see what the difference is. Maybe not that much, see, or if I move it down, it gets less of it. But I think that where it was at 200 is pretty good fit. So I'm going to go ahead and close the real-time preview, turn off the preview mask, and do a screen stretch so we can see what we're doing. Well, I'm going to apply this just to the preview to see what it looks like. We'll see. This should clean up a lot of this grain. Okay, I could live with that, especially for this image. And now the next thing I'm going to do is I'm going to use the script that I have for autocolor, and what it does is it just takes the background neutralization and the color calibration and combine it at the same time. But all you have to do is just click on it instead of run the other two processes. If you don't have this, I can leave in the description below where you could get these scripts. So the autocolor got rid of a lot of green without even doing an SCNR. So that was nice. And you could see our telltale SHO magenta stars, and I can get rid of those as well. So I think I'm going to re-screen stretch this, and it still has a lot of gradients. Now I'm going to go ahead and stretch this image. Lock it in. We'll apply that, reset, come back in again. Let's apply that, reset, and maybe just bring this up a little bit more, the midtones. I could pull this back here. Okay, I think that'll do it. Now that our image is stretched, I'm going to run an SCNR to get rid of some of this green. I'm not going to get rid of all the green. I think I'm going to try this at 0.85. So the nebula itself's looking pretty good. Up here is looking, still not looking that great, but I'm going to try and get rid of the magenta stars by inverting this. And now once I've inverted it, you can see all the green, because the inverse of the magenta stars is green. And I'm going to turn this up to 100 full, or 1.0 full, and then apply this as well. And I'm hoping that it also removes a little bit of our, the red that was up in here, gradient got removed. Okay, well, it's looking better, that's for sure. We can close that now, and we're gonna make a mask. And so I'm gonna use the range selection tool, and I just wanna mask out this area here, if possible. So let's turn on the real-time preview, and we're gonna lower the limit. It's not bad. Make it a little fuzzier. Let's try this. So let's apply that mask and minimize this. So we're gonna see. I'm not too worried about this star over here. I think what I'm gonna end up doing is cutting this, cropping this again to make more of a vertical image. And because I have to get rid of this here, and this star is looking pretty bad. So let's turn off the show mask so we can see what we're doing. And I think we'll make a preview, and I'm gonna try and run the HDR multi-scale transform. And what I'm trying to do with this tool is kind of do a deconvolution without running a deconvolution. Let's see what this looks like. Well, that's a lot of more. That was a little bit too aggressive, so I'm gonna undo this. So the number of layers, the higher the number, the less aggressive it gets, and the lower the number, the more aggressive. So I'm gonna try it with 8 instead of 6. No, how about 7? Let me undo this. That might work. I'm going to try this again. Now, I've still got my mask on, so this is only going to get applied to the mask. So only the nebulosity and not the background. Let's see, before, after. I'm gonna try this. we could delete that. We can close this. And now with the mask still applied, I'm going to go into curves, turn the real-time preview back on, and I think I'm going to see if I could give this a little bit more saturation. Apply that. Reset this. Give it just a little bit more. I normally wouldn't saturate this much, but I'm just kind of experimenting with the bad data. I'm going to give this a go and reset this, and I think I want to try and make looking for that more red, more purple look. Apply that. I'm just going to go straight to the red channel and see about lifting the reds up just a little bit. Apply that. And I'm going to reset this and then go to RGB and brighten it up just a hair. Might even do a little S curve here. Okay, now I'm going to invert the mask. So everything but the nebula is going to be affected, and I think I'm just going to bring the background down a little bit. And I think that's pretty good. Maybe just the tiniest bit more. I think that'll do it. Well, it's looking a lot better than it did when I first looked at the data, that's for sure. I'm gonna go ahead and remove the mask. And I'm gonna go back and do another crop. Let's see what this looks like. So unfortunately, it's still a little grainy. It's a lot grainy for an image that has 28 hours of data in it. I hope you liked this. If you did, please leave a like and don't forget to subscribe, and we'll see you in the next video.